play it in your sleep and see if it just sinks in. You might wake up with nightmares about derivatives. Alright. It's not letting me write hardly. Okay. Let me try this again. Derivative at a point. Okay, so for a derivative at a point, we can use the one that we just did. Limit as x approaches a of f of x minus f of a over x minus a. And there, a is a number. That is, no, for this one you don't use the h at all.
Wait, does that mean that it doesn't matter if you put the f of a first or the f of x, just on the bottom is the same?
Correct, yeah.
What?
Not important. Just do it like this. Okay, so this is your derivative at a point. If we need to know the slope of the tangent line at 4, you could use this. The other way that we found a derivative, which gave us the derivative at any point, this is the h one, and it is f prime of x. Here x is a variable, so you could replace x with any number, right? So if you use this, like what we just did up here, this only works at x equals 1. Because we plugged in that specific number. So this only tells us the derivative at 1, which is all we care about, and it's a little easier, so we're doing it this way. But sometimes we need to know the derivative for any point, and that is when we're going to do the limit as h approaches 0 of f of x plus h minus f of x all over h.
So how do you find a derivative at any point if the derivatives at certain points are different?
So what it's going to give you, like let's say that your function was f of x equals 3x squared plus 2x plus 1. Okay? So let's just say that's what we started with.
Sure.
I know a secret, so I can tell you that f prime of x is going to be 6x plus 2. And I'm going to teach you that secret today, and you'll be either very angry at me for not telling you sooner, or you will be very happy that I finally told it to you.
3 times the exponent and you bring that up.
So what this does, Thomas, is this is the derivative, the slope at any point. So if I want to know the point at when x is 1, I would plug in 1. And it'd be 6 times 1, which is plus 2, which would give me 8. But if I wanted to know whenever x equals negative 5, I would plug in negative 5.
So it gives you an equation, not a numeric.
Correct. Correct. And then you could plug a number in, and that will give you the slope at whatever point you're in.
Still considered derivative even if it's a function and not a number.
Yes. Yes. Okay.
So whack. All right.
Okay. All right, so just a couple other things that aren't really necessarily this section, but they were on that free response. What if they asked me for a horizontal, sorry, we're going to, oh wait, I think I answered that instead of telling it.
No, it's negative.
Horizontal
I got that wrong.
asymptote. Okay, so horizontal asymptote is the limit as x approaches infinity of whatever your function is. And you also at least need to consider the limit as x approaches negative infinity of f of x. Okay, this is not what we're doing now, but I'm just trying to summarize several things that we need to make sure we have straight. And what can we use for our horizontal asymptotes? Bobo, botno, or you can work it out. Eats DC. Okay, So if you see them asking for horizontal asymptote, limit as x approaches infinity. Yes.
Limit as x approaches negative infinity only needs to really be, is only really serious when it's like acting from the x.
That or piecewise function, you'll need to look at the, like if we were doing, what you did was fine because you addressed it. You like wrote down that you had thought about it, right? So you said like on the left that there's no horizontal asymptote because it's linear or something like that. I think. Yeah. So you got full credit on that. So you addressed it even though you didn't do the limit. So that's fine. But you at least need to show that you considered it. So you could do that by doing that limit or by mentioning something about there not being a horizontal asymptote on the side.
So what can you do with horizontal asymptote?
So whatever number you get for your limit, let's say you get a 5.
How do you get the number?
You're going to use ECC. So if I have the limit as x approaches infinity of x squared plus 3x over x to the 4th, what would I get? 0. So I would have a horizontal asymptote at what equals 0? Y equals 0, not x.
I didn't trust it at all in the test because I forgot what it meant. It's like I thought BO meant bigger on bottom of 1.
It's 0. Bigger on top, not 1.
Not 1?
Yeah, there's not 1 at all. It does not exist. No, it means there's not 1 at all. You're just basically going to do for that it does not exist. So it's positive infinity or negative infinity, but some of you guys are doing this saying there's a horizontal asymptote at negative infinity.
That just means there is a line number.
You can't have a line at infinity. That's not an asymptote. So if you get infinity or negative infinity, then it's just there's no asymptote for that. So don't ever put y equals negative infinity as a horizontal asymptote. That would be one. All right. Was there anything else I was going to summarize?
Yeah, I just want to write those down.
Okay. All right. I'm going to give you a worksheet. There are no problems on the front page. These are all functions and their derivatives. You're not working this out. What you're going to do is you're going to look at all these, and I want you to come up with a rule of how you can do this without having to do limit definition of a derivative. Because I think we can all agree that we're kind of tired of it.
Yes.
Right?
Absolutely.
So it's time before it's time for me to pull you back from the ledge.
Yes, the hole. Pull it out of the well.
Before you jump, and I'm gonna teach you the shortcut. This will hopefully make your life a little bit better. And I gave somebody an extra.
It's right here.
Well, pass that back. I think I need one more there for Eli. So some of these have. You guys have.
I got
Okay. Nobody has an extra. Eli. I don't have an extra. What happens if? Let's see. Let me see if I've got a blank copy in here. Let you have it.
yes.
You can write it however you would like. Oh, here's a blank one. Here, I'll have this one. I can always print another one. Here you go, Eli. thing on the front.
What you do is you take you multiply the exponent by the 1 in front of the x, and then you subtract 1 from the top.
Alright, so write that down as a rule for me.
I can speak about it.
Alright, then once you've written your rule, on the back, there are a bunch of problems that I want you to do using your shortcut. Write down the rule. I know some of us are opposed to actually writing down words. I will allow you to do your shortcut in, you can do your shortcut using notation instead of a sentence if you would rather.
No, it must be sense.
Well, let me tell you this, pretend the f of x equals a x to the n. You could tell me f prime of x equals.
Wait, are these right so far?
Yeah.
Well, I didn't do that.
I'm not gonna tell you this yet. But try them all, and then
So I don't
try
want to
all.
do the whole thing.
So I want you to try the first 15. Then the answer key is on Canvas. Check and see if you did the first 15 right, and then try the last there and see if you can get those right. That is coefficient, right? Yeah. Yeah, so these is you're like trying to figure out the patterns of what's happening. So you're looking for here we have x to the third, we're x squared. This one is x to the third, so we're looking for a shortcut that we could use that would give us that answer without having to if I told you you got 5x squared minus 4x, you could tell me that the derivative is this without having to. So look at those and figure out. So right there, you don't have any x.
Right.
So we have f of x equals 3. We don't have any x's, which I could write as 0 x's, right? 3 times 0 is 0. X to the negative 1, but it doesn't matter because 0 times x is 0. So your rule still applies. Treat it like it is negative 3/7 times x. Because when you got negative 3x over 7, if I did negative 3 over 7 times x over 1, then it would still equal this. So treat it like negative 3/7 times x to the Answer keys on campus. Check it there.
I don't know about that. This is demonstrating a function. Abstract equals a. Know that it needs to look like that.
Use your rule first.
So A is
Same
a
rule.
number, so the
Same
variable,
rule.
A is the x value, and then N is the power.
Use the rule before you write. So don't rewrite this one over. So use the rule before you write.
Finding f of prime is the derivative. F prime is the derivative. And
Yes.
I can kind of explain it in my brain, but like, what do you notice about this function relative to the other ones? Like, there's no x or
So you want everything to be, you want it to look like an explanation first. And then you change
well,
it.
like, this one is just f of x, the function is f of x equals 2. And the derivative is equals 0. What is the hell we have this? So since there's no x,
Did I not put it on campus?
Are you talking about the answer key?
like there's no x.
Yeah.
Oh, I think it's not an assignment. It's just a-
F prime equals 0 and x is if it's just f, if f prime 1
Yes.
is 0, that's just the first pattern. And then if it's just the number, but then the other ones you can kind of see.
Yeah. I'm not gonna lie. 16 to 27 is kind of confusing.
They're a little more.
Slow, yeah.
Where are you getting x to the third?
Yes,
No.
you right. So you're right. This line.
Wait, Miss.
This right. You're right. This one.
Pretty much. I didn't write it out. You're forced to f of f prime equals
I would like it, but if you haven't put it, I'll make it. Yeah, start doing it then.
all these that you not have in this one here, f prime is
So, you're using the same rule for all of these. But, when you have something like, where, X, for example, like with X to the, I can't use my rule and I can put up the square root. But I could write this as X.
It's the power of 5 over 2.
Okay, what's your rule tell you that you're
Oh, that you can then multiply that by
5 halves X.
to the power of 3 over 2. And then that's your answer.
If I might have written it back as square root of X to the third.
Okay. So that's okay. Bust it out.
Right.
Oh, yeah.
I'll have minus 1. Yeah, so same rule. It's harder to do because you have to write.
It really makes no sense. You multiply it. So you like 1 times 2, and then you subtract the next one, which adds it to the bottom.
So, like, let's go.
I'll take that as the Did you say how you do calculus? I'm using calculus with the analysis.
In this particular case, like right here, right, 9x cubed becomes 3 becomes 9. Let's say, okay, your x If I was going to write it in symbols instead of words, how could I do it?
I did f prime of x equals n times a, if there's an f, minus, like, what is it, minus 1.
Minus 1n, like that. Okay, you're almost right.
It can't be. I was gonna say it can't be minus 1n. That just be turning it negative.
N minus 1.
Well, then you got to deal with fractions and all that stuff.
Okay.
So that means that there's got to be like. Is there another way?
It may or may not be fractions.
Is there? Okay. So there's not.
This rule works every time. Does it work if you just have f of x equals 4?
Yeah.
Oh, yeah. Yes.
It does because this has 0 x's behind it.
I was just write the same rule over and over.
So 0 times 4 is 0, subtract 1, but it doesn't matter that this is x to the negative 1 because it's multiplied by 0, which is just 0. So f prime of x equals 0.
Yeah.
It works for all of them. Yeah.
So,
So f of x, like even if it's like a 3x, that's x to the first power. So f prime of x is 3 times 1, which is 3. X to the 0. What is x to the 0? It is not 0, 1.
Wait. Now, can you do like
Not yet. Y'all are still in
That's
figuring it out
I
mode.
just need to do the
Addison, use your critical thinking skills.
I have like 3 questions left.
If you're getting down to the bottom part of the worksheet, there's a couple things I probably need to remind you of. If I have 1 over x to the third, how else could I write it?
It'd be x to the negative third.
X to the negative third.
Okay, that makes sense.
Then I could use my rule, right? What about if I have the cube root of x to the 7th?
That is one that, it'd be x to the 3/7.
Not quite.
7 and 3.
7 over 3. So roots can be rewritten as fractional exponents. Fractions can be rewritten with negative exponents. And then you're still using the same rule.
So,
You could move it back down to the bottom and change the roots again if you want. I was not consistent on which one I did there. I think pretty much what I was doing there is like these problems have fractional exponents to begin with, so let's say fractional exponents, whereas these had roots to begin with, so but you could do it either way. Since you got that negative significant, if you want to write it, yes, it'll go. Because it's subtracting, it's down, but it looks like it's up. There will be no x in the top there. Because when you move it to the bottom, so do each one separately. So
did all that without checking.
Make it negative exponent so that you can use your rule and then take that.
Do we have to change it?
You don't have to.
But like if it was on a previous farm, we could technically leave it as a negative. We could just like simplify.
Okay, I know everybody's not finished with that last part, but I just want to do some quick notes to summarize this. I'm going to give you your book assignment that you're going to do.
Oh no.
So, let's...
What? What?
It was on AP Classroom. We have not gone over it, but I think we might do that tomorrow.
What? Did you discuss that?
I thought you
He
let it
just
fly.
left it.
Just let it go and move it down.
Just let it fly.
Okay. Alright, so, if you have not already,
Where do we ask for beer?
I would write down, this is called the power rule. So this is a little bit different notation. When I write d over dx, that means the derivative of. I would write this down, yeah.
I didn't know if we had like a note.
Yeah, this is going to be, no, I did not print these today. They're just going to be quick to jot down. You should be able to fit it on one, I think.
How about how?
Half would probably work. They're not going to be terribly long.
Now, the d over dx, that's just like same thing as f prime.
It's like, it says take the derivative of x to the yeah. And you don't have to copy down some of these problems, we're going to do them, but I don't want you to copy them down because that's just going to take you longer than need be. So that power rule, we multiply out front by the n, we subtract 1 from the exponent, which most of you guys were figuring out, right? That's more or less what you were telling me to do with your shortcut rule. And this is what we call the power rule. It is the most simple of all shortcut rules that we are going to learn. We are going to learn other ones as well, but it's the most simple of all shortcut rules. What? 12 rule? No. I didn't say 12. No, not 1 of 12. We'll also learn the power rule. This is the power rule. I always get power product rule, quotient rule, and chain rule are going to be the other 3 big ones that we're going to use. Alright, so don't write these examples down because we're going to do them very quickly. I want to do them to make sure you guys are with me. So, for this, Logan, what is the derivative of x to the third? So, and make sure when you're doing this, I need to say f prime of x equals 3x to the second. So when I'm working on a free response question, I'm going to label it f prime of x so that it is clear to the grader that is my derivative and not the original function. So make sure you're labeling this. So Chandler, what would I get for my derivative? Yeah. Daniel, talking to you. What would I get? Chandler, what would I get for my derivative here? Make sure you label these f prime of x since you weren't paying attention, so that you can get points on a free response question instead of me having to take everything off. I know it. I would have been shocked if you had. All right, Chandler, what would we get for this one? Perfect. All right. All right. So, alright, so this stuff I'm just going to run through with you because it's stuff that kind of just, like, shows up.
Do we ask for different?
You don't have to write this down. So if I take the derivative of a constant, so a constant is just a number, I'm going to get 0 every time. We showed why that is, because if I can use my rule, 3x of 0 would be 0 times x of negative 1, which equals 0.
So 3 is a constant.
Right, so 3 is a constant, or 7 would be a constant, or negative 100 would be a constant. So if you're taking the derivative of a number, you just get 0. If you have a number multiplied by whatever you're taking the derivative of, it just sort of hangs out there and was multiplied. You've already done this on that last question, 4x to the 5th. You said 4 times 5x to the 4th. There, so we've already been doing that. We've really already done this. Sum and difference tells me if they're added or subtracted together, I can just take their derivatives separately. We were already doing that. Because if I asked you, Thomas, to do number 1 for me here.
We got 12x to the third minus 12x plus 3.
And that's it, because that 1's just going to be a 0, because that's a constant, right? So you were already using those properties because you were taking the derivative of each one of those separately. Okay, so let somebody else say, Luis, tell me what we would get for g prime of x for number 2. Perfect, right? So shortcut rule, no problem. All right, here is where you might want to start writing down to make sure you're with me on these. Okay, so y equals 1 over x to the 5th. I can't take the derivative of with it looking like the fraction as it is. But how could I rewrite this? X to the negative 5th. And Margaret, what would I get whenever I take my derivative? Very good. And I like that she got that negative 6. There's probably somebody out there that was thinking negative 4. But you're subtracting 1 from the 5. Negative 5 minus 1 is negative 6. But I myself sometimes put negative 4 because it just seems backwards, right? And then, so you could leave your answer like this, or you could throw that back in the denominator like that. The 5 does not go with it.
What if you did do the 5? Would that be wrong?
That would be wrong. Yes, only the x goes to the bottom. Free response, you can leave it either way. It's just going to depend on what answer choices look like if it's not free response. Whenever you do your homework tonight, check your answers in the back of the book and try to make sure you've got a match in what's there. Okay? Again, questions on 3?
That's number 16 on the thing.
All right. Number 4. I've got to rewrite this before I can do this. How could I rewrite the cube root of x? 1 over 3. Roots are on the bottom of a tree, Thomas. So whatever's out here is your root. It goes on the bottom of your fraction. Yeah. Yeah. So, and there's a 1 right there. So 1 over 3. So for when I take this derivative, f prime of x is going to equal 1/3 x to the, I've got to do 1/3 minus 1, which is 1/3 minus 3 over 3, which is negative 2/3. So I got 1/3 to the negative 2/3. They might leave it like this, or they might move it back down to the bottom. So you could put the 3 is already in the bottom of a fraction, so you could put this down here with it, x to the 2/3. And you might even see them do this, 3 cube root of x squared. Yeah. Yeah, you don't have to do that. all three of these are, like on free response, you could leave it here if you want to. But what was your question, Selena? Because our rule tells us to multiply up front and then subtract 1 from your exponents. Okay. So, all right. So, for a problem like this, find the slope of the graph of f of x equals 3x minus 4x squared at 1, 0, and negative 2. So if we want to know the slope of the graph, what are we looking for? Derivative. Okay? So what is the derivative of this? 8x.
Oh, yeah.
So if I want to know the derivative at 1, I just do f prime of 1 and just plug in 9 times 1 squared minus 8 times 1. So 9 minus 8 equals 1. And then same function, different spot. Slope at 0, I would do f prime of 0. Which is just going to give me 0. And then at negative 2, I'd have 9 times negative 2 squared minus 8 times negative 2. So it'd be 9 times 4 plus 16. So 36 plus 16 would give me 52.
So if we were to show like that work right there, would that be enough for like a free response?
Yes. So if it's on free response, do not ever do limit definition of a derivative again. If you can do this, okay? So like on the free response question that you just did, part A of the first problem where you had to expand everything and do all that limit definition of derivative,
I know.
if you look at it again, you can tell me it's f prime of x equals 4x to the third minus 6x squared without having to do any work, right? So you don't have to do limit definition of a derivative again.
So in theory, I should get 4 points at least.
It will probably not be worth 4 points if I'm not expecting you to do limit definition of a derivative, but you should get that part.
It's negligible.
Yeah. It'd probably just be a 1 point section now that we can do it so easily, but but it's going to make it much easier. And Thomas, what you were asking earlier, so what we found here, like this gives us the slope at any point. So at 1, my tangent line has a slope of 1. At 0, I have a slope of 0. At negative 2, I have a slope of 52.
So we're finding any point, not a point.
Right. Okay, questions? Okay.
Is any of this like what the homework can be like so far?
Yes. All right. Okay. Let's do a tangent line problem. It's going to be so much easier. So much easier to do a tangent line problem now. So we want the equation of the line tangent to f of x equals 1 over x squared at x equals 1. It's going to be ridiculously easier than it was before. So, for a tangent line, you need to do three things. Alright, so we need a point on the graph. Alright, so point on the graph. How do we find the point on the graph where we have this tangent line? Plug into the original equation. So we're just plugging in 1. This was the same as we were doing before, right? So to get your point, plug into the original equation. We get 1, so that tells us that 1, 1 is our point. Then we need the slope. And here is where we're going to do our derivative. Okay? So slope is derivative. You do not have to do limit definition of a derivative anymore, unless it's one that we can't use the power rule on yet. So f of x is x to the negative 2. Notice I labeled that f of x. It's not f prime. I haven't taken the derivative yet. Right? When I take the derivative, I have to label it as f prime, and I'm going to label it even if my name is Daniel Bautista and I hate labeling anything. I'm still going to do it because I want to get a good grade on things. So when I take this derivative, it's going to be negative 2x to the negative 3. I think this is a little bit easier if we go ahead and move that back down to the bottom and put our x to the third here. What? You can leave it with the negative, but what you're going to have to do, because this is my slope, but it's not my slope at 1. If I want to find my slope at 1, what do I have to do? Plug in 1 into f prime, and I'm labeling this by showing f prime of 1. And so in this one, it doesn't make a lot of difference because it's just a 1, and 1 to any power is still 1. But if it was a 4, it's going to be a little bit easier if you don't have those negative exponents. So we're going to get negative 2. That is our slope. Limit definition of a derivative. Yeah, we just did it like 5 minutes ago.
I'm convinced you pretty much set us up for failure on that one.
I have to teach it to you. I'll show you some of the types of problems that you will see on the AP exam where you have to know limit definition of a derivative. But I have to teach it to you. But all right, and then our line, this is where we use y equals m times x minus x1 plus y1. So y equals negative 2, x minus 1 plus 1. And leave it like that. Don't simplify it. I mean, you can, but if you mess up, you're going to lose your point, even though you had it right. I know, it's so easy compared to the way it was, right? So tangent lines have hopefully just turned into a dreaded awful problem into one that, hey, I might could do that. Mm-hmm.
No, that's actually exactly what it is.
1 over, it just looks so, 3x cubed plus x squared plus 2x.
Then you would have to know how to do something different that we don't know yet. Because you can't just move that stuff up to the top if you've got plus or minus signs. So there's going to be a different way that we can do those, but we're going to have to use some different rules that we don't know yet, but we're going to learn soon. So right now, I'm not going to give you that type of problem. All right. Okay. Yeah. I promise. This is what I'm talking about. I'm telling you guys, this is so easy. It is maybe like this much harder than what we've just been doing, but it's so easy. Just copy down what's in these blue boxes and quit whining.
I refuse.
This is like whenever I tell Henry to go take his shoes upstairs. No, I can't take my shoes upstairs. It's so hard. Walking all the way up the steps. Yeah. You don't make Hunter take his shoes up the stairs. I did teach Hunter how to take a derivative one time. I bet he does. I'm sure he does not remember it because it had like no meaning to it, but he could do it, like using this rule, you know. It's yet to be determined, really.
It doesn't get determined until about 6th grade.
Yeah, I think it's when algebra shows. I mean, he does pretty well in math, but he doesn't like super impress me with his intellectual math skills. But he's only in 5th grade, so we'll see. We'll see. We'll see. I don't know. Sometimes I get the feeling I might be raising a B student, and he's driving me crazy.
Hey, you still get the grade. You just have to pass the grade. Passing grade is
Sometimes that's fine. Sometimes you can do better.
hey, same paper at the end of the day.
Okay. All right. So this is. You have to have these two memorized. If you don't have these two memorized, you'll have trouble with trig.
How many things have you memorized?
So the derivative of sine is cosine. The derivative of cosine is negative sine. Without teaching you about integrals, I can't answer that really well. We're not going to go into answering that question, although there is an answer to that question, but we don't have time to do that. So, all right, watch this. If I'm taking the derivative, the coefficient just stays the same. Cosine turns into negative sine. And so that's going to be negative 2 sine x. That's it. I'm not going to answer that why question right now because I do not want to spend a extremely long time explaining it and confuse people further. But there is an answer to that question. I'm just not going to tell you right now. Yeah, this is multiplied right here because these are multiplied. So it's 2 times negative sine, which just gives us negative 2 sine. All right, so number 8 here. We've got sine x over 2. All right. Sine x over 2. We need to think about this as 1/2 times sine x. Because if I multiplied those back together, right, that's sine x over 1, I would get sine x over 2. So I can think of it like that. So I'm just going to have 1/2. Derivative of sine is cosine. So 1/2 cosine x. That's my derivative. You could also write it as cosine of x over 2.
That's how it was written initially.
Okay. All right. All right. Then the last one, it has a mixture of power rule with trig rules. So what's the derivative of 2x? 2. What's the derivative of sine? Cosine. You're done. It is, but that minus sign was there in front of it.
Are we done for the day?
Oh, okay.
Give us just the homework. Right, we're good.
Yeah, that's the homework that we were doing.
Yeah, we're not gonna do that right now. Okay.
Yeah,
All right. Let me make sure we can do all this. There might be a couple I need to take off.
Oh, that's a lot. Oh, wait, no, it's 3 to. Oh.
These should be. You should be able to do 3 through 29 odd in like
Is that just the simple?
in like a few minutes before you leave, even. All right. So I'm gonna check and make sure. I might take a couple of them off, but I probably it should be like the back side of that worksheet. It should go fast. All right. 3 through 29 odd. Oh, let's see. I need to take a couple of these out. Okay. Let's do 3 through 21 odd. Then 39 through 49 odd. And then let's do 55 and 56. It's a lot of problems, but these should go pretty fast. I need to show you one thing that I did not show you. Look at 43 really quickly. Or I will. F of x equals x third minus 3x squared plus 4 over x squared.
Oh, that's sick. Would that be 3?
Oh, you have to like.
Bring that 6x. You can't have 2x minus 6x over 2.
Okay, so this x squared that's in the bottom, there's a couple ways you can think about dealing with it. Okay? Because you cannot, there is a quotient rule that we can use, but we don't know that yet. Plus, it wouldn't be the best thing to do on this because it's not the easiest way. So, we can do what I sometimes call the love connection. I told you about the love connection, didn't I?
Yeah, you did.
We can, this is a triple love connection.
Love.
So, we could divide all these things by x to the third, and x squared. So, x to the third divided by x squared minus 3x squared divided by x squared plus 4 divided by x squared. Now, this is still f of x. I've not taken the derivative. So, f of x would equal x to the first power minus 3 plus 4x to the negative 2. I have not taken the derivative yet. That is just the function, right? I'm rewriting it so it's in a form where I can take the derivative. So then you would take the derivative after that. That's part of it. You'd have 1, because derivative of x is 1. What's the derivative of negative 3? 0, it just goes away. Then you'd have negative 8x to the negative 3. Which you can leave like that or send that x to the third back down to the bottom. Actually, let me just keep going because the back of the book gives the answer like this. X to the third minus 8 over x to the third. What'd they do?
They moved the negative x to the.
They did it incorrectly.
Like that.
What?
Alright, you guys are alright with moving this back down to the bottom, right? How'd they get x to the third minus 8 over x to the third?
If you do, that would be like 1, and it would be 1 minus 8.
Common denominators. Yeah.
That's kind of redundant though.
X to the third minus 8 over x to the third.
Is that redundant?
It is fine to leave it right here if it's true response. I do want you to look at the back of the book and try to get your answer to match the back of the book.
I don't have the back of the book.
Just take a picture of it. In the back of the book you have. back.
Just like dumb
The answers are in the last section of the book. It has selected answers. All the odds have answers to them.